Let's talk about a force that's all around us, every second of every day. It shapes our weather, it powers our technology, and yet we can't see it at all. We're talking about pressure.
I'm going to bet the answer is yes. And no, I'm not talking about your job or your deadlines. I mean, you, right now, are literally physically under an immense amount of pressure. And it's probably way more than you think.
Okay, get this. The huge column of air that stretches from the top of your head all the way to the edge of space, well, it's pressing down on every single square inch of your body with about 14.7 pounds of force. That's like balancing a bowling ball on every inch of your skin. It's just the weight of the air, and it's a constant force we've all just gotten used to.
So, what is this invisible weight really? How do we actually define it? Let's break down the science behind it all.
At its most basic, pressure is just force divided by area. Think about it this way. A sharp knife cuts through a tomato so easily because all that force is focused on a tiny, tiny area. That's super high pressure. On the flip side, a snowshoe lets you walk on snow because it spreads your body weight over a really big area. That's low pressure. Simple, right?
So that 14.7 psi we were just talking about, that's what we call atmospheric pressure. It's literally the result of Earth's gravity pulling down on every single molecule of gas in our atmosphere, creating this thick, heavy blanket of air that presses down on everything. And I just love this quote. It's from Evangelista Torricelli, the guy who invented the barometer way back in the 17th century. He put it perfectly. We don't just live on Earth, we're living deep at the bottom of a vast ocean of air. All right, so if we're living at the bottom of this ocean of air, what happens when we start to swim up towards the surface? Let's see what happens to pressure when we go higher. It's actually pretty simple when you think about it. The higher you go, the less air there is stacked on top of you. It's kind of like a pile of books. The book at the very bottom is getting crushed by the weight of all the others. But the book at the very top, it has nothing on it. It's the same with the air. Less air above you means less weight pushing down, and that means lower pressure. And if you want to see this invisible force in action, this is one of the coolest ways to do it. If you seal a plastic bottle way up on a mountain, you're trapping that thin, low-pressure air inside. But when you bring it back down to sea level, the much heavier air pressure outside just completely crumples it. It's pretty dramatic. This is basically the same thing that happens inside your head. You know that feeling, right? When your ears pop on an airplane or driving up a steep hill? Your inner ear has a little pocket of trapped air. As you go up, the air pressure outside drops fast, but the pressure inside is still high. Your eardrum bulges out until, pop, your ear releases a tiny bit of air to even things out. Okay, so we've gone up, now let's do the opposite and head down, way down, underwater, where pressure changes much, much faster. This is where it gets really crazy. Under the water, you've got the weight of the entire atmosphere plus the weight of the water above you. And water is so much heavier than air. Just going down about 10 meters, that's around 34 feet, is enough to add a whole other atmosphere of pressure. You've literally doubled the total force crushing your body. So, what's the deal here? Why is water so much more powerful than air when it comes to pressure? Well, it all comes down to three things. Its density, the pull of gravity, and how deep you are. And when you're comparing different liquids, the one that really matters is density. And just look at this table. This really shows you how much density matters. Mercury is more than 13 times denser than water. So if you go just 1 meter deep, the pressure in mercury is over 13 times greater than it is in water. It's not just about how deep you go. It's about the sheer weight of the stuff that's above you. But you know, pressure isn't just some wild force of nature. It's something we've learned to use. We actually put it to work for us every single day. You've probably noticed this yourself. You check your tire pressure, go for a long drive, and then check it again, and it's higher. Why is that? Well, as you drive, friction with the road heats up the tire, which heats up the air inside. Those hot air molecules get super energized, start flying around faster, and slam into the inside of the tire more often. All those extra impacts, that's higher pressure. All right, now this next idea is a real game changer in engineering. It's called Pascal's law. It's such a simple concept, but it's incredibly powerful. It just says that if you have a liquid in a sealed container and you push on it, that pressure spreads out instantly and equally to every single part of the liquid. And this is the magic behind how things like your car brakes or a hydraulic lift work. You apply a small force on this little piston, right, that creates pressure in the fluid. Thanks to Pascal's law, that exact same pressure travels over to the big piston. But because the big piston has a much larger area, that same pressure produces a way, way bigger force. It's like a superpower, a real-life force multiplier.
Okay, let's zoom way out now, from tiny pistons to the entire planet, because these same pressure differences in our atmosphere are what create our weather.
You've definitely seen this on the weather forecast, right? The big blue H and the big red L. That H marks a high-pressure system, where heavier air is sinking, usually giving us calm, clear weather. The L is a low-pressure system, where air is rising, and that's the recipe for clouds, storms, tornadoes, and even the biggest hurricanes. In fact, the center of the strongest storms are always areas of incredibly low pressure. So, when you put it all together, from the little pop in your ears to the brakes in your car, all the way up to the massive power of a hurricane, pressure is this constant, powerful, and usually hidden force that's just fundamental to how our world works. Once you start to understand it, you really do start seeing it everywhere. So, I'll leave you with a question. Now that you know what to look for, where else can you spot this hidden force at work all around you?